Now, as always, we want to wrap up every lesson with actual practice problems. So to illustrate the importance of knowing the parent graphs, we're going to use this question from the SAT, and let's go ahead and read it. Which of the following equations has a graph in the xy plane for which y is always greater than or equal to -1? So let's read that one more time. Which of the following equations has a graph in the xy plane for which y is always greater than or equal to -1? So choice A, hopefully you recall that this is an absolute value function, and the parent graph of an absolute value function is y equals absolute value of x. So we've transformed this graph some way. Hopefully you remember that this -2 transforms the graph. So if we were going to graph this one, we would have y-axis, x-axis. Let's calibrate this a little bit. We have -1, -2, -3, and so on and so forth. We learned that the graph of an absolute value function is a V-shaped graph, and the -2 is a transformation that moves the graph down 2 places. So typically the graph is here, but then it's actually been moved down 2 places. So really it's actually here now. So we can see that A wouldn't work because we wanted the graph where the y is always greater than or equal to -1. Well, here y is -2, so it's less than -1. So A failed. Let's repeat that process for B. If you remember, once again, this is the parent graph for a quadratic function. And what shape does a quadratic function have? Yes, so the parent graph of it is usually like that. Let's actually calibrate this just like we did the other one. -1, -2, -3. But then you can see there's a -2, which again is a transformation where? Downward. So the graph is actually moved down 2 places. And again, this one fails because we wanted a graph where y's are greater than or equal to -1. So this one fails because it's lower than that. Therefore, we can eliminate B. Okay, let's go ahead and try C. C is what type of function? If you've guessed quadratic, very good job. So once again, I'm going to calibrate the bottom of this. So we have -1, -2, -3. So we see that this is a transformation because the parent graph of a quadratic is usually y equals x to the second. And that gives us a parabola, which is that U-shaped graph that looks like that. However, this -2 is a transformation where? Correct. So that moves the graph to the right 2 places. So the graph would actually be here. Let's see if that's the answer we're looking for. We wanted the graph where the y value is always bigger than or equal to -1. Yeah, the y value here is definitely bigger than -1 because the y value is 0. So C would have to be the answer. But just to prove why D isn't the answer, let's have a look at it. So D is a cubic function. How do we know? Well, y equals x to the third. And if you remember from the Desmos exercise, cubic functions look like this, squiggly lines. Well, that clearly has a lot of y values that are smaller than -1, so D cannot be the answer. And that is why C is the correct answer to this question.